Alright, so today we learn about sensors as this has been covered in FS 122. Some of the topics covered will be a review of those who have already taken food physics in the new curriculum. So marami siguro sa atin na nakaka-realize na meron tayong sensors sa ating mga bulsa, no, sa ating mga smartphone. Like a smartphone should have a temperature sensor, usually a compass, an altimeter, barometer, a sound measuring device, and a light measuring device, aka the camera. So these are not much different from the sensors that we can see on a food manufacturing facility, albeit the scale is much larger. So sa mga food manufacturing plant, ganun din, may mga temperature tayo. These are usually inline sensors. For example, if in continuous processes, you have an instantaneous temperature measurement device for the product flowing through a tube. And at the same time, you would need to measure, for example, their flow rate to know how fast you're producing things and to adjust the other parameters such as the rate of heating and for other things that could affect product quality and safety. But what are sensors? No? In simple terms, these are things that detect, quantify, and usually displays through a humanly recognizable reading, either a physical stimuli or biochemical compounds or reactions. So anything that could translate these physical stimuli or biochemical reactions into something quantified and humanly understandable, usually in numbers, are sensors. So there are different types of sensors based on how fast they can provide results or where they are. So online simply means that there's a real-time measurement. So this could be like your thermometers that could display changes in temperature in maybe a second or less, or weighing scales. We have inline sensors, which are online sensors but located in the product flow stream. So these may include, again, of course, your flow meters because they measure instantaneous volumetric flow rate, at line or near line. So these are techniques that are relatively fast and are not exactly in line but are very close. Let's say like a laboratory that is adjacent with a window, like a drive-through window through um, the production area, for example, has a quick viscosity assessment that only takes seconds. And offline, these usually refer to either a facility that is on-site or off-site of the manufacturing, but usually delivers results in a much slower pace. Of course, when you're producing lots of food, it's generally important to have a very fast pace in delivering results. You cannot wait for days or hours to have your results because you have to adjust your production parameters very fast, like in a matter of seconds or at most minutes. Sensors in the food manufacturing are usually for either process control or quality control. If you have process control sensors, these are usually those things that you analyze so that you can have instantaneous changes to, let's say, the operating machine or equipment, while the quality control tools are those that um, adjust the necessary parameters either in the process or usually in the process so that your products will be properly manufactured. So online sensors usually require rapid response of up to just a few seconds, if not nearly instantaneous. Unfortunately, the usual physical, chemical, or microbial tests that we do can take maybe hours, minutes, or even days for results, such as in the case of plating, where you wait for the bacteria to grow. However, you can use tests which rely on physical quantification of physical attributes to proxy for chemical or microbiological attributes, as you will see later. On the other hand, kapag gumagamit tayo ng physical sensors to measure chemical or biological reactions, we usually have to calibrate these sensors to the product because they measure things indirectly, like they produce electrical, pneumatic, or hydraulic signals that can be used to convey chemical or biological reactions, such as, for example, measuring luminescence as a proxy for microbial load. And therefore, there has to be some sort of correlation or calibration for this to work. So kapag meron tayong mga aircon sa bahay, may mga settings yan. Pag automated, you set the temperature and the internal controls of the equipment try to achieve that, let's say, aircon temperature that is set to 25 degrees. And this is done through a control system. First of which is meron siyang sensor. So sensors give you, let's say, the readout na ano na ba yung temperature. Okay, 27 pa lang, 25 yung need natin i-achieve. And then you have an adjustable process device which can cause the parameter of interest, in this case temperature, to increase or lower. Like you have a set of compressor fans, blowers, or heaters. And then you have the controller, yung pinaka-utak, na based doon sa readout ng sensor, siya yung nag-a-adjust ng adjustable devices para ma-achieve. Paano ba natin ma-achieve yung 25 degrees? Do I increase the compressor's operation rate, yung fluid flow ng refrigerant, and so on and so forth. And usually in HACCP and quality management, you want these automated operation equipment to do the work for you para ma-maintain yung food safety standards, let's say when we have temperature control or other product quality standards. So taking for example your room air conditioner, the sensor is the AC, the thermometer inside the aircon unit. The adjustable process device will be the compressors and blowers, which turn off and turn on or increase or decrease their operation rate, yung pag-ikot nila, lakas ng pag-ikot, and the controller, which is the computer that tells the compressor and the blower to work harder or turn on or turn off. Okay, so what happens is the aircon turns on. If you press the device to set at a certain temperature, the sensor measures the initial temperature and then it adjusts the operation of the blower and compressor until the temperature is reached. And then repeats from step, it measures the temperature again and then adjusts kapag nagtaas or nagbaba masyado yung temp from the setting. So pag sinabi nating closed loop ay mag-isang gumagana yung sensor controller process device. Automatic siya in short. Pag open loop naman, wala siyang sensor. So meron lang siyang adjustable device pero mano-mano yung pag-adjust such as when you have your stove, electric fan, or gripo. But it may contain shut-off switches such as yung mga electric fan na may timer. So in terms of adjustable process devices, meron dalawang klase yan. Yung nag-on lang at nag-off, like non-inverter compressors and motors. They only have two settings. And then those with variable speeds. Now, some may be infinitely variable or some may have multiple steps like yung electric fan na may 1, 2, 3. Okay? This is generally more expensive pero mas nakakatipid ka dahil sa precision control. So one downside to sensors is they have a physical limitation, kung gaano kabilis sila mag-respond. Okay, so usually may lag time kaya hindi agad nakaka-compensate na nag-drop na yung temp pero hindi pa nagbubukas yung compressor mo or nag-increase na yung temp pero hindi pa nag-on yung compressor. Okay, and usually how usable a sensor is dependent on the application, kung gaano kabilis kailangan mag-adjust. Kasi kung sa food manufacturing ito, a delay of a few seconds could mean na meron kang product na off specification, like kung temperature yan ng isang conveyor belt oven, ilang loaf na ng tinapay yung nasunog bago nag-adjust yung sensor mo, or ilan na yung nahilaw bago nag-adjust yung sensor mo. So absolute and relative measurements, pag sinabing absolute, kung ano yung mineasure niya, yun talaga yun. Like kung timbang, timbang talaga. However, meron namang ibang relative measurements na kailangan ng calibration. Halimbawa, if you're using voltage as a proxy for flow rate, then you'd have to calibrate na itong voltage na ito yung magiging flow rate niya. Kasi pag hindi mo kinalibrate yan, erroneous yung magiging reading mo. It measures voltage, but the voltage is not correlated to the actual flow rate. So yung mga absolute, mas maganda silang gamitin, pero yung relative usually mas mabilis for certain applications. Okay, so terms muna tayo. Pag sinabing sensitivity, it's detecting small changes, incremental changes, like sa timbangan, kung nagdagdag ka ng ilang taktak ng asin, ma-detect ba to? Pag sinabi namang selectivity, sa dinami-dami ng dapat sukatin, ay kaya mo bang sukatin yung bagay na yun, like isolating a specific wavelength of light. Ang specificity naman is, kaya mo siyang sukatin, pero kaya mo bang sukatin nang hindi nag-i-interfere yung ibang bagay, like measuring only that wavelength of light and not other things, walang interference. Detection limit is ano yung pinakamababa or pinaka lowest level na kaya mong sukatin. Like kung may timbangan ka, usually hindi mas malaki yung sukat ng maximum na weight ng timbangan mo, mas malaki din yung minimum weight na dapat nandun para ma-detect niya na, uy, may nakapatong pala sa akin. And pag sinabi natin stability, especially in industrial settings, kailangan itong sensor na to ay shockproof, dustproof, kaya mag-withstand ng vibration at kung ano-ano pang harsh environment. So maraming klase ng food sensors sa manufacturing. Na-discuss na iba dito sa food physics sa iba sa inyo, but we'll just run through them, and some of them we'll discuss dun sa respective topics na talaga sa FS 152. Okay, weighing principles sa Earth na ito, dahil may gravity tayo, we can take advantage of gravity to weigh by measuring the downward force that an object produces, no, kapag nakapatong siya sa isang something. And usually, meron niyang either mechanical, like yung mga outdated na spring scales, or usually yung mga bago ngayon, electronic weighing devices which uses either a load cell or electromagnetic type, the summary of operation which could be seen here. So sa food manufacturing, yung iba't ibang mga specialized na weighing equipment, andyan yung belt weighers. Habang dumadaan sa conveyor belt, nakakasukat siya so it doesn't interrupt the operation by having to stop. Optical check weighing, so measurements bulk material by laser or x-ray para mabilisan din. Okay, multi-head weigher. So usually kapag meron kang yung kailangan sakto sa timbang tapos may mga pieces of different weight. So may mga individual compartments na nilalagyan tapos siya na yung nagbabalance doon kung papaano. Okay, sa next slide meron yung example. And then check weigher. So ito lang yung may feeling na nagaganap before, tapos pagdating dito sa check weigher, sinusukat niya kung overweight ba, underweight, or nasa tamang timbang, tapos i-reject pag mali yung timbang. So for density measurement, you have your anything that measures mass and at the same time measures volume. If you combine this, then you have a density measuring device. So sa laboratory scale, here are the different devices. They usually measure by a fixed amount of volume or weight of a substance na correlated in density and do some calculations, although some are automated and some are novel, like using X-rays. So in oscillating systems, you have hollow tubes na nagko-contain ng liquid samples, magva-vibrate yung hollow tubes na yun, and based on the frequency of that vibration, we can, with calibration, know the density of the materials in question. So here's the example of the oscillating system for density measurement. So papasok yung fluid dyan, tapos aalog siya up and down, and then merong oscillation measuring device that gives a readout, and based on the calibration, translate the oscillation into a density. So although it's automated, the principle here is that if you know the density of your reference material, and then you compare the oscillations, then you could just the computer automatically calculates using the following equations, as for example here in measuring beer density versus the reference water and sucrose solutions. So almost all food safety plants like HACCP plants usually require metal detectors because the real threat of metals in food, usually through intentional or accidental contamination, mga stapleware, ganun, is real, no? So metal detectors, nangyayari, meron kang papasok sa isang electric field dito sa part na to, yung iyong products na nasa conveyor belt, and then based on the change in the disruption in that magnetic field sa calibration, pwede mong malaman kung meron bang metallic object of sufficiently large size na nakapasok doon. Of course, this needs to be calibrated as well. So entirely important yung flow sensors. You can watch the video in the link below. Okay. And maraming klase ng flow sensors. Two major categories are either being obstructive or non-obstructive. Pag sinabi natin obstructive, So usually ito ay based on mechanical work. They will take some of the kinetic energy ng flowing fluid to be able to measure its flow. Okay? Typically, these use propellers o flow restrictors like orifice. So, i-discuss naman din yan sa ibang topic. However, there is a risk for sanitation and cleaning because there are moving parts. So, kaya mas preferred yung non-obstructive sensors, one of which is thermal flow. So, merong based on the temperature gradient and calibrated siya na kasi nga temperature dependent. So, based on the change in temperature, they could predict the flow rate of the product. So ultrasound flow sensors, on the other hand, pass sound waves through flowing fluid. Okay, and then it does some calculations. So yung pulses niya on multiple directions, and then nagka-calculate siya based dun sa time ng pagbalik ng ultrasound kung gaano kabilis yung daloy ng tubig. It also, of course, needs to be calibrated because of, among other things, is fluid dependent on, to say, the density, among other things. So this one uses a similar concept ng oscillation dun sa density measurement natin. However, ang ginagawa naman ngayon is based on the oscillation and the Coriolis forces, kinakalculate naman niya yung velocity ng fluid instead of the density. Okay. For measuring the liquid level in the tank, a number of different paths are possible. One is to use a float, a buoyant object attached to a mechanical device that mechanically gives you the length or the translation ng level. Displacer, so buoyant din siya, pero ito naman, pressure sensor yung ginagamit. So yung nalutang-lutang na displacer dun sa fluid, nagko-contact siya dun sa isang force measuring device, and of course, depending on the liquid level height, nagbabago din yung force na na-measure ng device. Differential pressure sensor, may pressure sensor sa baba ng tangke at dun sa pinaka headspace niya. And then the difference between the two pressures can be calculated from there yung liquid level height. So ultrasonic level transmitter, so parang ganun din sa flow. Since static naman yung fluid sa loob, pero kapag mas nabawasan yung fluid sa loob, mag-iiba din yung time ng pagbalik ng ultrasonic waves. So left to right lang, so ito yung dun sa displacer na schematic. This one naman is for the pressure sensor, and this one is for the ultrasound pulse. So itong refraction sensor is just an inline version of our handheld refractometer. Of course, meron siyang parang light measuring device na rin, okay, and it gives you a readout of the refraction index in real time. So chemo and biosensors are usually more complicated, and they combine both a signal transducer and biochemically sensitive layer. And when substances adsorb on the sensitive layer, pwede siyang mag-transmit ng ibang output. So we'll see examples of this later. Optical-based systems, as you can see here, itong luminometer, so meron siyang, if you swab the surface, mapipick up niya yung microorganisms which produce adenosine triphosphate, and then they conduct a chemical reaction which is done by snapping this portion. So ito yung swab. Tapos magpaproduce ng ATP, and then they measure the ATP and correlate the strength of the emitted luminescence to the amount of microorganisms present. It's also useful for antibody antigen and toxins and microbial activity in general. So here's a sort of passive sensor that relies on time temperature indicators depending on the amount of ethylene absorbed. The colors on the packaging change, and it gives you an indicator of the ripeness of the fresh produce. So generally, these smart packaging communicate to the customer or the trader depending doon sa color na yun. So they could either measure temperature, gas, microbial growth, toxins, or allergens. And of course, again, they would tell you through usually color changes kung ano na yung status ng product. They're also useful for detecting the thermal history, kung na temperature abuse ba during transport yung bagay. na yun. So in this case, the colorimetric freshness sensor for fish measures hypoxanthine, and the amount of hypoxanthine is used to proxy for it relates to the color change in the detector, so you can see how fresh or how deteriorated it is, so as it ranges from the bluish to green to around brown, yellow, and to pink. In this case, we have wireless nanosensors that are connected to control units and can transmit information from anywhere in the world with signal. Okay, these nanosensors would tell how the grain status is and would automatically adjust the components that would affect the grain or would prevent the grain spoilage during storage. So on this part naman, we have an allergen detection strip. Okay, there are different allergens which can be detected using the strip. And depending on what the results are, pwede mo malaman kung ano sa different allergens yung meron doon.